Oh, good gosh, golly gee willikers. It's been so long since I made a video that, like, I didn't know where anything, anything was. I was looking for my software, I was looking for the headphones, but I found everything. So here we go. We are going to do a couple problems. This first one is going to be law of sines. The way I know that it's law of sines is I know that I was given an angle, right, a side, and a side, and that side that I was given is across from the one angle, and so I know that I have the ambiguous case of law of sines. Now, we have in class been making sure that we were dealing with angle A and side A, and then this, this middle side right here, that one in the middle should be side B, so we can just go ahead and kind of rewrite that, and that's okay. Now, we know that our A is 7 and our B is 20. So we know that A is less than B. And remember, if A was greater than or equal to B, then we had one triangle. If A is less than B, we had to set up our law of sines ratio. And if we got a number back, then it was two triangles. If we got an error message when we were plugging that into our calculator, then we got, or there are no triangles. So I'm going to set up the ratio, and I'm going to do a sine of A over A equals the sine of B over B. And I'm going to plug in what I know, and I know that sine of A is sine of 20 over the A is 7, and I don't know angle B. That's what I'm looking for, but I do know side B is 20 feet. I cross multiply and divide. Remember, I'm skipping a couple of those steps like I do in class. So it's 20 times the sine of 20 all over 7. We have to remember that I'm looking for the angle right here. So when I'm looking for that angle, what I have to do is say that that angle equals the inverse sine. Right? Inverse sine. You flip-flop the fraction and the letter. When you do that, you do inverse sine of 20 times the sine of 20 over 7, and you just let your calculator do all the work. The only thing that you have to remember is when you're plugging this in, please make sure you close your parentheses around that actual angle measure. When you do that, your angle that you get on your calculator is wrote it down, 77.7. Right? And as we have done with everything else, we're going to take our angles and we're going to round them to the nearest degree. So that's 78. And then we're going to take our sides, remember, and round them to the nearest tenth. Now, again, because we actually got a number right here rather than an error sign on our calculator, that means we have two triangles. And when you go and do this, you draw your two triangles, and we just kind of keep it simple. We've got one triangle with two acute angles on the bottom, and then we have one triangle with an acute angle on the left, an obtuse angle on the right. And as always, my triangles look nothing like what they're supposed to. It's okay. We're just filling in. We just have that little bit of a short and sweet diagram right there so we have a visual. You are always given angle A in both triangles. You're always given side B in both triangles, even though it may have to be renamed, obviously. And we always have side A in both triangles. So fill in what you know. You know this was 20 degrees for both of them. You know B is 20 feet for both of them. And then A is 7 feet for both of them. And I apologize, guys. I'm trying to keep this small so I can fit it all on one page without having to do a lot of scrolling and all that craziness. Now, you look at your angle that we found when we did our ratio right here. We got 78 degrees. You ask yourself, is 78 degrees acute or obtuse? Hopefully at this stage of the game, you know it's acute. So it's actually going to go into our acute angle right here. Because we got to remember that across from side B is angle B. Okay, so across from side B is angle B. So angle B is right there, and of course we're going to look for angle C and side C. Now angle C is very, very simple, right? We do 180 minus our 70 minus our 28. Okay, we get our 82 degrees. And then the only thing we have left to do now is actually find side C. And then once we've done that, that first triangle will be complete. So I can write sine of A, right? So sine of 20 over 7 is going to equal the sine of 82 over C. Okay, this one's nice because I'm just going to cross multiply and divide. I don't have to worry about the inverse or anything like that because I'm finding the actual side measure. So when I do this, it's going to be 7 times the sine of 82 divided by the sine of 20. And when I do that, C is going to equal, what did I find? What did I find? 20.3. Okay, 20.3. So I go and I enter that on my calculator, 20.3 on my calculator. Sorry, on my drawing. And I've got that one triangle complete. Now I do want to just double check. Remember, double check these guys. Across from the smallest angle, 20, is the smallest side, 7. Across from the middle angle, 78, right here, is 20, which is my middle side. And across from my 82, all the way across there, is my 20.3, which is my biggest side. So smallest angle, smallest side, biggest angle, biggest side. Just double check that. It doesn't hurt. It takes an extra 5 seconds, and you know that you've done it correctly. Now that you've got the first triangle finished, you go and finish the second triangle. And remember, the second triangle is so much faster. You're going to find angle B, angle C, and side C again. The nice thing is, this angle B, you're just going to do 180 minus the first angle B that you found. So 180 minus the 78. When I do that, I get 102. So there's my obtuse angle right there, 102. Okay, and that changes my angle C. My angle C becomes a 58. And now I just have to do one ratio real quick. And I'm going to use the same thing that I used for the first triangle. I'm going to use my sine of A over A. So sine of 20 over A, or over 7, sorry, is going to be the sine of 58 over C. Sine of 58 over C, when I cross multiply and divide, I will get 7 times the sine of 58, and I will divide it by the sine of 20. And then I will get my C is, wrote that one down too, 17.4? It would be terrible. I can't even read my handwriting, guys. 17.4. Okay, so 17.4 feet, running out of space there. 17.4 feet, and then again, just double check. Across from the smallest angle, smallest side, 20 and 7. Middle angle is 58 and 17.4. Those are middle numbers. And across from biggest angle, biggest side, 102 and 20. All right, and that covers your one example. I can't do 400 of them for you. I apologize. I know I should just, eat, sleep, and breathe math and stay here all day, every day making these videos for you. Not that any of you watch them, but that's fine. So here you go. You've got the entire thing done. It is one example of angle side side or side side angle, the ambiguous case of law of sines.